Hello everyone, in today's lecture we are going to discuss about the division algorithm, how the division is being performed in the computer architecture that we will discuss in today's lectures. Division of fixed point binary number in signed magnitude representation. That means how to do the division for the signed magnitude numbers. Division of signed magnitude number is done using the paper and pencil method by a process of successive compare, shift and subtract operations that we discussed in the division part 1 video. Binary division is simpler than decimal division because the quotient digits are either 0 or 1, because in binary division there can be only two values, that is 0 or 1. So it is simpler than the decimal division because there is no need to estimate how many times the dividend or partial remainder fits into the divisor. One condition in the division in computer architecture, that is divide overflow. So what is divide overflow? The division operation may result in a quotient with an overflow. That means the number of the bits in the quotient can be more than the number of bits in the divisor. That generates an overflow condition. So there is one flip-flop required to handle that overflow, that is called as DVF, or you can say divide overflow. It is a critical problem because the length of register is finite. To store the overflow bit, an additional flip-flop, that is called as DVF, divide flip-flop, is used in computer architecture. Provisions to ensure that divide overflow condition is detected must be included in the hardware or the software or in the combination of two. So what is basically overflow condition? When the dividend is twice as long as the divisor, the condition for overflow can be stated as, that means if the divisor is having 5 bits and the dividend is having 10 bits, then there may be overflow, which can be stated as a divide overflow condition occurs if the high order half bits of the dividend constitute a number greater than or equal to the divisor. That means overflow condition or overflow situation occurs when the value of dividend is greater than or equal to the value of the divisor. In that case, division overflow condition occurs. But if A is less than B, that means dividend is less than B, then there is no such condition. So there is one more situation in division process, that is divide by 0. In division process in computer arithmetic, that is divide by 0. So it must be avoided. The divide overflow condition takes care of this problem as well. So how the overflow condition is handled in the division process? Programmers check the DVF after each divide instruction and then branch to a subroutine that takes corrective measure. That means a programmer checks every time the value of the DVF, if it is 1 and if it is 0. According to that, the process will be done. Second is divide stop. In some older computer, the occurrence of divide overflow stop the computer. Now here this is the flowchart for division algorithm. Here you can see that dividend is stored in AQ register. Here AQ is a combination of two registers. We require two registers to store the dividend, and divisor is stored in B register. Suppose we are having the value 10001. That means there are 5 bits in the B. But in dividend, suppose the value is 00010. Now here you can see the value is smaller than the value of divisor here. So we need additional bits in the dividend. So that's why store the value of dividend. So size of dividend is double than the size of divisor. So after that, the sign bits of AS and BS, that means the sign of A register and sign of B register, are compared using the XOR operation, and the final sign bit will be stored in the QS flip-flop. After that, sequence counter will be initialized with the value n-1, and then the value of EA will be A plus 2's complement of T. That means A and B are subtracted here. So after that, the value of E will be checked. If the value of E is equal to 0, that means A is less than B. Okay, so if A is less than B, then A plus B will be done and the result will be stored in EA. In this case, when A is less than B, there will be no divide overflow. That's why in divide overflow, 0 will be shifted. But if E is equal to 1, that means the value of dividend is greater than or equal to the value of divisor. In that case, A and B will be added and the result will be stored in EA. And when the dividend value is greater than divisor, in that case overflow occurs. So the divide overflow flip-flop value will be equal to 1 and the process will end in this case. But if the divide overflow is equal to 0, then it will move to the shift left operation. So here it's written shift left EAQ. That means the content of EAQ will be shifted in the left position. So here again the value of E will be checked. If the E is 0, then A will be added with 2's complement of B and the result will be stored in E register. After that, the value of E will be checked again. If the value of E is equal to 1, that means the value of last bit of dividend will be set to 1. If E is equal to 0, that means the value of dividend is less than divisor. The B will be added and the result will be stored in EA register. After that, sequence counter will be decremented by 1, and if the sequence counter is 0, then the process will end and the quotient will be stored in Q register and remainder will be stored in A register finally. Okay. But if sequence counter is not equal to 0, then this will move to this shift operation again. Now here, if E is equal to 1, after performing the shift left operation, if the value of E is equal to 1, then A will be added to the 2's complement of D and the result will be stored in A. But if the value of E is equal to 0, the result of A and 2's complement of D will be stored in EA register. So here, if E is equal to 1, that means A is greater than or equal to B. Okay, that means dividend is greater than or equal to the value of divisor. In that case, the value of Qn, that is the last bit of dividend, will be set to 1, and after that sequence counter will be decremented by 1, and again the value of sequence counter will be checked. In all the division process occurs. Now here, how we can check the divide overflow flip-flop? Subtract the divisor stored in B from half of the bits of the dividend that are stored in A. That means here you have to compare A and B. If A is greater than or equal to B, that means there will be overflow bit and it will be stored in the divide overflow flip-flop. But if dividend is less than B, in that case there will be no divide overflow. So if A is greater than or equal to B, DVF is set. That means DVF value will be equal to 1 and the operation will be terminated and no overflow occurs.